All right, guys, welcome back. We want to start getting into what your book refers to as the ambiguous case of the law of signs. Okay, you have this in your notes that I posted on Google Classroom, and this is right in your book too. And your book actually does a pretty good job of explaining this stuff. But we're going to go through it to let you see exactly what could possibly happen when you're given two sides and a non-included angle, because there's four possibilities that could happen, and I'll show you why. Okay, so again, you can run this off or you can download it onto your computer. It's right in your notes for the week. Okay, but it is these four cases that could possibly happen. I want to explain to you what's going on here. Okay, now I have a tendency to use a diagram real similar to this guy. So you'll see me do that on a regular basis. Okay, whether or not you use that same diagram or not is up to you. Okay, so I have some triangle A, B, C, or at least I think it's a triangle. Might not be a triangle, but I have three segments, and I'm thinking I got a triangle, and I'm just going to call it A, B, C. Okay, so we have one angle, which is non-included, okay, and two sides. So I have a tendency to always put that angle that I have. So let's suppose we know what angle A is. Okay, now, once again, I'm not sure if I can form a triangle or not. That is possible. Okay, so I'm not actually going to draw one. Okay, I'm going to kind of leave it like this, and this guy might keep coming down and might form a triangle, and it might not. I don't know. Okay, so I know this angle, and I know two sides. Okay, and this has to be a non-included angle. So I'm going to call this little a because it's going to be opposite angle A. And I'm going to call this little b. Okay, so now let's suppose I know what the length of little a is, and I know what the length of little b is, and I know the measurement of angle A. And notice I would have side, side, angle. Okay, so if little b is here, point B would have to be somewhere down here. Okay, and then obviously this would mean that point C or vertex C would be up there, and okay, little c would be down here. Okay, now one fact that plays a big part is the height of this triangle, if it is a triangle. Okay, so we have this height right here. Okay, and we say, okay, well, how can I figure out what that height is? Well, notice if I use this height, notice that I have a right triangle right here. Okay, and I could say the sine of angle A would be opposite over hypotenuse, so it would be the height over B. So solving for H, notice that your height always ends up being little b times the sine of angle A. Okay, and that guy's real important here. Okay, so let's see the first situation. Okay, how about we suppose that the height is greater than A. So the height is greater than A. Okay, so whatever little a is, whatever that is, let's suppose like little a was, 10 centimeters, and the height was 15 centimeters. So the height is greater than little a. Then notice there is no way to swing little a down and even make a triangle. It's just going to sort of like hang there, okay, because the height is too high. So little a couldn't even reach down to this side and form a triangle. So if the height is greater than A, this means there is no triangle at all. We can't even form a triangle. Okay, so that's one situation that could happen. Okay, all right, so another situation, okay, how about we suppose that little a and h are the exact same measure? Okay, so how about we suppose that h is equal to a. That means I could take this side length, which is a units long, and swing it straight down, and it would lay right on top of h. Okay, so if a was, 12 inches, and h was 12 inches, I could swing that 12 inches right on top of the h, and obviously we have a right triangle. Okay, so if that happens, okay, we have one right triangle, okay? And then obviously you could go about your business, okay? No big deal. Obviously there's nothing to solve in this first situation because we can't even form a triangle. Right here, we have a right triangle, so you could either use the law of sines or just go back to your basic trigonometry and solve it using right triangle trigonometry, sine, cosine, tangent, whatever you need. Okay, so let's see. What would be the third situation? Okay. Well, notice we want to form a triangle here, so to do that, little a has to be bigger than h. So that means that, say, for instance, little a was, say, 18 meters, and the height was 10 meters. That means that that 18 meters could reach down and touch, okay, and actually form a triangle. Okay, so what if we have a is greater than h? Okay, that means we can form a triangle. But, okay, we have two situations here, okay, where a could be greater than h. Okay, so let's suppose a is greater than h, and it's also greater than b, okay? And a is greater than b. Okay, so for instance, let's suppose a is 20 meters, okay? H is 15 meters. So you have the 20 meters greater than 15 meters. So we know we can definitely form a triangle, okay? But notice that if A is greater than B, would we say A is 20 meters? Let's suppose B is 18 meters. Okay, there's no way for me to swing little a back under, okay, and form another triangle. It would have to swing all the way past, okay? And so you would have little a coming out over here, okay, if you tried to do that. Okay, so if A is greater than H, we can definitely form a triangle. And if A is greater than B, we can only form one triangle. Okay, so we have one triangle. Okay, and it wouldn't be a right triangle, okay, because A would have to be equal to H for it to be a right triangle. So this would be a non-right triangle. Okay, so now here's the one where it gets a little dicey, and this is where you get the ambiguous case. It could be two different ones. Well, what if rather than A being greater than B, what if A was less than B? Okay, so there's actually two different things that could happen. Okay, and I'll show you in a diagram. Okay, let me move this guy up a little bit. I want to make sure we can get all this stuff in here. Okay, so we have a triangle like this. Okay, here's your A. Okay, here's your B. Okay, here's your C. Your H is in there. Okay, and we know that A is less than B, but A is greater than H. We have to have little a greater than H just to be able to form a triangle. Okay, but we also know that little a is shorter than little b. Okay, you could have this triangle, or notice I could take this side length, and since it's shorter than b, I could swing it over to the other side of the H and form a second triangle that would look something like this. Okay, where there's your A, here's your C, but now your little a is coming in like this. And so you have this B here. Now your height is still the same. Your height is still the same. Your little a is still the same. Your little b is still the same. Just notice it changes little c. So this is where we can end up with two different situations, two different triangles. If you have little a is greater than h, obviously we need that to be able to form a triangle, but little a is greater than b. It gives you two different triangles. Okay, so we have four possibilities here for scenarios when we have two sides and an included angle. So the first thing we have to do is figure out, well, which scenario are we in? You know, and then we go from there. Okay, so we'll start off, we'll get one out of the way today. and see what happens with it. Okay, so starting right here, the very first thing I always do is sort of diagram things, okay? And then I'm going to go back to this sheet, and obviously you could use this guy as well, doesn't make any difference. And we got to figure out which situation we're in, and that'll tell us how to proceed. So I've got triangle ABC, okay? So I will use the same exact diagram that I used on the other one. Okay, here's my A, okay, and so little a is over here, okay, and little a is 81 units long. Okay, little b has to be right here because I need to have side-side angle, okay? So little b's right there, and that's 62, okay? And then the measure of angle A is 43 degrees, okay? So the first thing I have to do is find the height. Okay, so here's my height. Okay, so remember, your height is always little b times the sine of angle A. Okay, and so we go little b, which is 62, times the sine of angle A, which is 43 pesos. And then you just go to your calculator, and I'll pull out my trusty Walmart special. Okay, and I go 62 times the sine of 43, and don't forget, make sure it's in degrees, because we're using degrees here, not radians. And I get 42.28, so 42.28. So my height right there is approximately 42.28. Okay, so I have to compare H and A, and then A and B. Okay, so let's see what we have. Okay, notice that A is greater than H. Okay, A is greater than H. So this means I can definitely form a triangle. Okay, there's no doubt about that. I can definitely come up with a triangle. Now it comes down to, do we have two triangles or one? Okay, I don't know. Okay, so that's where you go back to either this right here, okay, or this sheet right here. Doesn't make any difference. Okay, so now compare A and B. So notice that A is greater than B because 81 is greater than 62. So if you go back up here, what happens when we can form a triangle and A is greater than B? We have exactly one triangle. Okay, so we only have one triangle here. Okay, so this means we have one triangle, forms one triangle. Okay, so I only have one triangle to solve. Okay, so we know we can form a triangle. Okay, so we go to what we have and figure out what we're looking for. Okay, so I have my A here, my 81 here, my little b is 62, so angle B has to be opposite that, so obviously this is C. Okay, and I know that this guy is 43 pesos. Okay, all right, so let's see. We're using law of sines, so I'm going to set up my three ratios. Okay, so I have the sine of angle A, which is 43 degrees, over the length of the side opposite, which is 81 units, equals the sine of angle B, over the length of the side that's opposite, which is 62 units. And I have the sine of angle C over the length of the side opposite. Now you could call it AB, obviously it's the length of side AB, or you could call it little c. It's just a matter of what you want to do. I'm going to call it AB. It makes no difference. Okay, now we know we're only getting one triangle. Okay, and we look at our three ratios, and obviously this is my cornerstone ratio, okay, because I have both the numerator and the denominator. Okay, so we take a look at what can we do here. Well, I can set it equal to this guy and solve for the measure of angle B, and I can set it equal to that guy, and I got a problem there. Because notice, I know both of these, but notice over here, both of these are unknowns. Okay, so I've got to work with this guy and this guy because there's only one unknown here. Okay, I've got a problem here. I've got two unknowns. I don't know the measure of angle C, and I don't know the length of AB. So let's start with this guy equal to that guy, and let's go from there. So we take the sine of 43 over 81, and we set that equal to the sine of angle B over 62. And then we use our cross products. Okay, so we get 81 times the sine of angle B equals 62 times the sine of 43 pesos. Okay, I want to get sine of angle B by itself. So the sine of angle B, I got to divide both sides by 81. So we get 62 times the sine of 43, all divided by 81. Okay, now I need the measure of angle B, so I got to use sine inverse here. Okay, so the measure of angle B will be sine inverse of, I've got to put this entire thing in there. So I got to be careful with my grouping symbols because I'm going to punch it all in at once and just hit enter. Okay, so I've got to separate the numerator and the denominator using grouping symbols. So I'd have 62 times the sine, and we know that that guy pops up automatically. So 43, so that guy goes with that guy, so I need another guy there. All divided by, okay, 81. Okay, like that. Okay, so I'm going to punch that guy right in there and see what happens. Okay, I'm in degrees, so I go second, sine inverse. Okay, the bracket. Okay, got that parenthesis. Okay, 62 times the sine, and one parenthesis pops up 43, so I need a parenthesis to match the 43, then another parenthesis to separate the numerator from the denominator. And then that is divided by 81. And then I need a parenthesis, okay, and hit enter. And it gives me, remember we're in degrees here, 31.47 pesos. Okay, so the measure of angle B right here, okay, is 31.47 pesos. Okay, now the problem we come back to when I take my cornerstone ratio, I set it equal to here, I have two unknowns. There's no way to find this length without knowing angle C. It's impossible to do. So I have no choice but to use an approximation for angle C, and I'll apply the triangle sum theorem. So right here, the measure of angle C, we go 180 minus 43, and then minus this approximation, 31.47. And the only reason I'm doing it this way is because there's no other way to do it. So we go 180 minus 43 minus 31.47. I want to make sure I got that right. 180 minus 43 minus 31.47, hit enter. And so I am getting 105.53 pesos. Okay, so that is my measure of angle C. Okay, so now I know what angle C is. Okay, so now I can take this, set it equal to this, and solve for AB. Okay, so I take my sine of 43 over 81 equals the sine of angle C, and we know that that guy is 105.53 pesos, and obviously that's an approximation, but it's a good one, over AB, and now I can solve for the length of AB. Okay, so we take our cross products, so we get AB times the sine of 43 equals 81 times the sine of 105.53 pesos, and then we divide both sides by the sine of 43. So AB equals, okay, 81 times the sine of 105.53, all divided by the sine of 43. Now I'm going to punch that entire thing into my calculator, so I need my grouping symbol. So I need grouping symbols to separate the numerator from the denominator. Okay, I know I'm going to get a grouping symbol here when I punch in sine, so I need a second one to go with the angle. Same thing here, I'm going to get a grouping symbol there when I punch in sine, so I need a second one for the angle. And then we go ahead and use our trusty Walmart special. So let's see, parenthesis, 81 times the sine, parenthesis comes up, 105.53 5, 3, and I need parentheses for the angle measure, and then parentheses to separate the numerator from the denominator, divided by, I need a parenthesis, sine, and parenthesis pumps up, 43, so a parenthesis for the 43, and then a second parenthesis to separate the denominator from the numerator, and then just hit enter. And I am coming up with 114.43 units when it's rounded off. So this guy is 114.43. And we should be in good shape here. Okay, so that is the first problem dealing with the ambiguous case, and obviously we're going to get into some more here tomorrow because the toughest one to do, okay, is this last situation where you have two different triangles. You got to solve for both of them. Okay, so we will get into some problems like that in the very near future. Okay, you guys take care, be safe, practice your social distancing, and stay away from the zombie virus. Miss you all.